Sorry, I feel a little nervous. The last time I gave a talk like this, I fell spectacularly off the stage. I shall try not to do that again, even though it does make it much more memorable for everybody watching. So, the guidelines for fresh produce safety, I've got a number of copies here, and I don't want to take them home on the plane, so I'm hoping I can give a few away. So this is an initiative of the Fresh Produce Safety Centre. I should say I didn't write all of this, I'm just the editor, responsible for trying to herd the cats that put it together. So food safety is obviously non-negotiable, so quality is really good, but without food safety you can't really do anything. So the aim of the guidelines was to provide a single consolidated source of best practice information for industry to use. So it's meant to be practical and usable. It was first created in 2001 at about the same time as Fresh Care, and a lot of the guidelines in this are consistent with what's in Fresh Care. It was revised in 2004, 2015, and this is the latest one in 2019. So, and I should just mention that the Fresh Produce Safety Centre Australia New Zealand is an industry-led organisation. It's entirely funded by industry, particularly PMA, and it's based at the University of Sydney. So, what's in the guidelines? Lots of stuff. So we have examples of hazards, whether they're microbial, chemical, physical. There are flowcharts of where contamination may occur. So this is an example of during packing. So it's just meant to be kind of a checklist so that you can look down this and think like, have I considered all the risks in these processes? There are decision guides for assessing risk as well. So this is for persistent chemicals in soil. I guess persistent chemicals in cold room, from what I've heard about DPA this morning, is, you know, exactly that sort of issue. So these sort of guides, I mean, the good news for apple and pear growers is that we go to the first one, do you grow produce where the edible part is in contact with the soil? No, finished, easy, easy, easy. So those are the decision guides. Then we've got lots of sections on managing all the inputs. So the orchard, soil amendments, water, chemicals, facilities, tools, equipment, blah, 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 blah. Workers, most importantly. This worker looks a little young. That's probably a risk. And then at the end of each section, there's a summary of the best practice. And then allergens and testing. So in this talk, obviously, I can't go through the entire contents of this document. So I'm just going to talk about some of the things which I thought were particularly relevant to this industry. So that is things like the soil amendments, compost, manures, water, workers, and also some of the tips on testing, because I think testing is really something of a dark art, and it's all very well to send a sample off for testing, but how do you interpret the results? So that's what I was going to talk about. So, of course, the hot topic, the controversial topic, is managing fertilizers and soil additives. And by this, what I'm really talking about is poo. Because, you know, microbial contaminants in manures, if they contact the produce, that's where the trouble starts. So microbial, but then there's also chemical, potentially from fertilizers, which can contain heavy metals, and physical contamination from foreign objects like glass and so on. So anyone who's done Fresh Care or other food safety certification programs would be pretty familiar with this kind of table, I should think. But when we're thinking about like, okay, manure, but what about compost? What about compost? Well, compost is exempt. But what do we mean by compost? And this is a critical point. Compost is something that has been produced in accordance with Australian Standard 4454, which is a nice big fat 80-odd page document. And if you have trouble sleeping, then this is a good place to start. But what all that boils down to, a lot of that is nothing to do with food safety. It's got to do with weed seeds and quality and particle size and this sort of stuff. The only thing that's in it that you really need to know is that the definition of compost is something that has been heated to over 55 degrees for at least 3 days times 5, which is quite a lot. So this is not something which has been left sitting in a pile for 6 months. This is something which has been actively managed. And then, you have to turn the pile, and this has to be documented and it has to be verifiable. So someone like Australian Native Landscapes, they can produce a certified compost product, which is then exempt from these requirements relating to manures. If it has not been produced in accordance with that, it's considered manure. It may be safer than just using manure, but it's considered as manure. So that's, I think, an important point. So this is windrows, your normal turning thing for compost, but we have in the guidelines, it does mention that if you are using something like these in-vessel systems which superheat the product and continuously turn it, then you can reduce that treatment time. But anyway, that is the important thing about composts. So if it may be aged, but it's not compost, then we have these withholding periods. So our withholding periods are 45 days for low-risk products, 90 days for high-risk products. And so what impacts on risk are things like, okay, does it have an edible skin? Is it always cooked? Is it, well, in the guidelines it doesn't say not washed, it says pathogen reduction step, which mostly means washing with a sanitizer. So is it washed? So you can see that the high-risk products are the ones which we regularly see associated with recalls and food safety outbreaks. Rock melons, lettuce. Blueberries are also there, but that's just so that the vegetable people don't get upset, mostly. So happily, apples and pears sit here as a very low-risk product. Not only are they not grown in contact with the soil, they're also washed. So happy days. But there are some caveats on this, because for one thing, I mean, that's in contact with the soil, but there is the possibility of dust, and that is what is believed to have caused the outbreak of listeriosis associated with rockmelon was dust. So caution does need to be taken. So there are a number of caveats. These periods of 45 and 90 days are significantly shorter than those used in other food safety certification programs internationally, and HARPs in particular. The die-off rates of human pathogens in soil are going to be affected by lots of different things, so UV, temperature, soil moisture, so on. But we have been verifying these withholding periods with a recent project looking at die-off rates of human pathogens in soil, and it seems pretty consistent. So generally you get a 2-log die-off within about 3 weeks. So it's quite rapid under our high UV conditions. So those are the caveats. So then we come to probably what is really more of an issue as far as what I think with my experience of this is water. So water is really a potential source of microbial and chemical contaminants. When you think about like the bacteria that make you sick, they live in your gut. They don't live in soil, they live in a wet environment. So water is actually a quite good environment for them to survive and multiply. Most food safety outbreaks, we can link them to contaminated water of some sort. So using clean water, including sanitizers, is absolutely essential in producing safe food. So if you think about the risk with water, the lowest risk is obviously going to be potable drinking tap water. Bore water is generally pretty clean, although last week I was in the Philippines and we took samples of bore water and they all had E. coli in them. So there's no telling. Then we go to canals, and of course the most risky is your typical farm dam where there are cattle wandering in and out of it and ducks sitting in it, and ducks are known to defecate occasionally. And then if you're using that to irrigate the harvestable part of the plant, then there could be an issue. So if we're talking about pre-harvest water, there are again withholding periods. So this is if the water cannot be verified as containing less than 100 colony forming units. So a colony forming unit is a single bacteria in 100 mils, then we have these withholding periods. So if you're not sure, then use the withholding period. And again, we have high risk and low risk. So in the case of apples, generally, water doesn't contact the harvestable part, it's low risk. But the exception is going to be spray applications. And so water used for applications of chemicals, pre-harvest, really should have less than 100 CFU per 100 mils. So there's a caveat to this too, in that what we have discovered as part of the project we've been doing, which is actually on vegetables, is that if the crop is damaged, then this does not apply. All bets are off. So this is the trials that we've been doing. We grew lots of different vegetables in the greenhouse and in the field. We damaged some of them, and you can see this cos lettuce, and just sort of cuddled it a little bit, and you get little tiny breaks. And then we watered on artificially contaminated water with E. coli and salmonella. And then every day we took a sample and we sent it off for analysis. So this is, it's missing, it should say days. So the undamaged product, you can see it drops from a log 3, which was about 2,000 E. coli per gram, which is quite a lot. It goes below 1, which is 10 E. coli per gram, within a day, because that's not a nice environment for an E. coli to live. But if it's damaged, you've made wounds. You've made little entry points for bacteria, you've provided them with nutrients, and they can survive a long time. And they can even multiply, which gets really scary. So the upshot of this is that if the crop has been damaged by frost, by storm, by hail, whatever, then this becomes really important. Because once these bacteria have entered into those wound sites, you cannot get them out. One of these trials we did, we damaged the plants, then we watered on the stuff, and then the next day we got 110 millimetres of rain, and it made no difference whatsoever. Another day we did it, and the next day was 40 degrees, and it made no difference whatsoever. Once it's in the wounds, you can't get them out. That's the important thing. Post-harvest water. So especially with apples and pears, you're using so much post-harvest water, like in the dump for cooling fruit, for moving the fruit in flumes, or washing pesticides, wax, all these things. And that water could be the last water that contacts the product. So for washing and cooling and treating fruit, we have these critical limits again. So for pre-washing, you can get away with it being a little bit dirty, but less than 100 CFU per 100 mil, like that's still pretty clean water. When we're coming to water dumps, flumes, final washes, that is basically drinking quality water. Because if that's carrying bacteria, then they could stay on there indefinitely, potentially. We also have to consider cleaning and sanitising the equipment, because that is also touching the product, and so that also has to use clean water. So less than 100 if it's not containing product, and drinking quality again if it's using the things which are touching the fruit themselves. And for hand washing, I would add. So water is really the key mechanism by which microbes can travel. To prevent this, of course, we add sanitisers. So sanitisers kill microbes in the water. But it's really important to understand that if it's already contaminated, they can't do anything much. So it's important to stop the contamination happening beforehand, rather than trying to fix up. It's not, the cool room and the packing line is not a hospital. So once they're contaminated, you can't do anything. Now, a lot of chlorine products are obviously the cheapest, the easiest, they're simple, but it's important to manage the pH. So, chlorine, this HOCl, that's the active form of chlorine. Once you go to a higher pH, it forms into Cl-, and Cl- doesn't kill microbes, but it does show up on the chlorine test strips. So I don't really work with apples and pears very much, but certainly with other packing sheds I've been to, you can put in your chlorine test strip and it says, yep, there's heaps of chlorine in there. But if the water is at pH 8, only 20% of that chlorine is actually doing anything. So it's very important to just be aware of that and monitor the pH. Of course, if it goes too low, then you end up forming chlorine dioxide, which is a poisonous gas, and you don't want that either. So it's just important to think that. Chlorine, it works by reacting with organic molecules, which is great, but that includes equipment, it includes workers, their skin, and so we get a bit casual about chlorine. I know, you go to bleach something and you put it in the bleach, and then your hands get that soapy feeling, and it's because the chlorine reacts with the oils on your skin and it makes soap. And I think that's a good illustration of how chlorine reacts with the human being. So it has to be treated with respect. Of course, there's lots of other sanitizers. There's nylate chlorine dioxide. E-water is a very interesting technology, and I know you've had talks about e-water before, and it sounds quite good. Ozone systems, I don't know if they're used in apples and pears, but certainly they've been quite popular overseas and for stone fruit, and they are not recommended because they don't work terribly well, or not reliably, as far as I can tell. So then we come to managing people. People, probably the hardest thing in any business to manage, I should imagine. And there's certainly a significant potential source of contamination. So we were talking before about how the staff numbers are being reduced in packing sheds, and those staff are becoming more highly trained. And this is a fantastic thing for food safety. It really is, because it is a major way of reducing risk. But it's important that workers have to maintain good personal hygiene. They shouldn't be handling fruit while they're sick. They shouldn't avoid physical contamination of products. So it's really mostly microbial, isn't it? They're not washing their hands, they're using contaminated water, they're using towels which are dirty, they're discarding their gloves, they're spitting, sneezing, infectious diseases, uncovered wounds. Oh, it's just too revolting to think about, and it's just after lunch, so let's not talk about that. Let's move along. So any worker who comes along needs to be toilet trained. And I know they're not puppies, but all the same, it's very important that people understand that they are handling something that somebody is going to put in their mouth and eat. And it's not just a thing moving along a line, it's food that someone will just pick up and they'll say, oh, yum, and eat it. So if they make that unhygienic in some way, put germs on it, and someone gets sick, how will they feel? So you've got to really, really get that message across. So all new workers should have food safety inductions. So this is, like I said, we do a lot of stuff with vegetables. We made a series of short training videos. They're about 3 minutes each, little modules, and it's about staying clean, washing your hands. This is my colleague in the centre. We have got my colleague Adam, not only going to the toilet with all his protective gear on, but then not washing his hands afterwards, despite the large sign on the wall that says, wash your hands. Then we have correct hand washing. I mean, if you're interested in these, even though they're for vegetables, I'm quite happy to give you the videos and the e-learning tools that go with them. They're quite available. Having these signs, and these are, you notice on the bottom, it's just got, those are actually Korean subtitles, and we've got Mandarin subtitles too. So they're available if anyone wants them. So for these sort of photographs, diagrams, cartoons using humour, I mean, does anyone say, oh, fantastic, I'm going to food safety training today, that's going to be fun? No, they don't. So you've got to make it interesting somehow. So, cleaning hands, yeah, this is, and what it mostly comes down to is cleaning hands, encouraging people to clean their hands by giving them warm water, giving them clean and tidy facilities, using paper towels, electric dryers. People just go zzz, zzz and walk away and their hands are still wet. So, using that signage in appropriate language. Gloves also obviously reduce that need, but, disposables are best. But if they are using reusable gloves, and in one of these pictures she certainly is, then they need to be washed regularly, because otherwise you're just cross-contaminating all over again. So then we come to intentional contamination. We had a long debate about whether this should be in the guidelines at all, because this is not a food safety issue. This is sabotage or terrorism of some sort. It really is. This can be planned, it can be opportunistic. Who knows why people do these things, just so they can get in the TV, perhaps. So the key things to do to make sure this doesn't happen is ensuring workers are treated and paid according to the law. All the others, transparent workplace cultures, all these things can help, but making sure that people are treated correctly, I think, is really key. So finally, we come to testing. So testing, everybody does testing because you have to as part of your program. But testing is, well, I didn't realise that I kind of made this link, a needle in a haystack, but it is a needle in a haystack. You're testing 10 grams of a product and you're going to find, how many bins in a cold room. You're going to extrapolate from that. It's like extrapolating the universe from a piece of fairy cake. It's a bit crazy. What it can do is it can verify that things are working correctly and find gross contaminations. That's all it can do. So, of course, we test for persistent chemicals, heavy metals, chemical residues, and microbial contamination. There's a whole lot of information in the guidelines about how to sample, where to sample from, when to sample, that sort of information. So I just thought I'd run through, because we did a lot of looking at other people's test results, and you can see some people test for coliforms, some for fecal coliforms, some for E. coli, some for Estec E. coli. What are all these things? And so, okay, I had to go through this myself to understand it. So there's a large family of bacteria which live in your gut called the Enterobacteriaceae. Salmonella is one of them. Within that, we have total coliforms. Within that, we have the thermotolerant ones, and within that, we have E. coli, and within that is a very small group of half a dozen species are the ones that actually make people sick. So the sugar toxin E. coli, like dysentery, which is Shigella. So we're using E. coli as an indicator because it's very convenient to do so. Just because you find E. coli does not mean anything is unsafe to eat. That's a key point. Listeria, so people test for Listeria species or Listeria monocytogenes. Listeria species includes things like Listeria innocua. It is everywhere. If I sample enough of that glass pane there, I'll find Listeria. I'll find Listeria in the soil outside. I'll find Listeria in the toilets. I'll find Listeria probably on the plate that I had for lunch. It's everywhere. What's important is Listeria monocytogenes, which is the only one which makes you sick. And then within mono, there's only actually a few strains that make people sick, and you have to eat a lot of cells. The dose, like you can eat a few salmonella and get sick. Listeria, you have to eat like 10,000, more than 10,000, and you have to be immunocompromised. But the death rate is high, about 30%. So consequences are severe. So that's what we're testing for. So I would say don't worry about total coliforms, just test for E. coli and just test for Listeria mono and Salmonella. They're the things. So when you send it off to a lab, they do various tests. So for E. coli, it's direct. They don't enrich the sample. They just grind it up and they put it on a plate, which is selective for E. coli. You count the colonies, that's your answer. Nice and straightforward. Salmonella and Listeria, they enrich the sample. So there might be only one cell and they can bring it back to life and find it because they use these phage technology, bacteriophages, and even one live cell, the bacteriophage detects it, it fluoresces, and they give you a positive detection. So again, just because you find a positive detection does not mean that that product is unsafe to eat. It just means that you should look further. The same goes for Salmonella and Listeria. And then they can confirm it's alive or dead using a different method. But yeah, they're very, very sensitive tests. So you can get quite a lot of positives which are alarming but do not mean that it's a disaster. Doesn't mean anyone's going to get sick, put it that way. Nonetheless, we have these are critical limits. This is from FSANS. So for apples and pears as a ready-to-eat product, E. coli, satisfactory less than 3 CFU per gram. We've got this marginal area, unsatisfactory more than 100. You can see the total coliforms are going to 10,000. That's how crazy it is. Like, this is a huge family. It doesn't mean anything. Salmonella, just detected and not. Listeria, detected and not. But Listeria, again, see, monocytogenies, I don't know if apples and pears support growth of this bacteria or not. I don't know. But you could see how it changes the tolerance of it. So Listeria, just test for Listeria mono, don't test for Listeria species. That's the thing. So in summary, consumers obviously expect they eat a nice apple or pear, and they're not going to get sick from it. It's not negotiable. Food safety requires effort. Sometimes it's confusing, often it's confusing, and often it seems a bit tedious. Like I said, does anyone look forward to going to food safety training? No. But it's really important, and that's the purpose of these guidelines, is to give practical information, make it easy, make you, help to ensure that food is always safe to eat. And that's it, because nothing says food safety like a frog in a bag of lettuce, does it? Thank you.